Hey everybody, this is Larry. This is day 9th of the February Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I'm still in Medellin. Hopefully that pronunciation's a little bit closer. And yeah, today's poem is 532, K-diff pairs in an array. Okay. So given nums and k, return the number of unique K-diff pairs. What is a K-diff pair? Okay, num sub. Okay, so that's pretty okay. So the way to do it is with a lookup table. I imagine. Just go from left to right, and then you count. The difference in both directions. And I think that's it. I don't know if there's anything tricky about it. And I'm scrolling down only to see if there's any like weird, like additional follow-up to make this problem more challenging. But that's basically what I would do. And I think this, so by itself, this is actually maybe a easy problem, say, but this idea of a lookup table that you update as you go from left to right or right to left. I guess it doesn't matter, because if it's right to left, you just reverse the array. So I just say left to right. And this idea does come up in a lot of kind of prefix dynamic programming solutions as well. I mean, of course, in that case, you add an element of the prefix sum in there, either in a linear space kind of way or just a lookup kind of way. But so even though this problem does seem easy, it is good to practice that kind of fundamentals of thinking about just these state transitions and I think like the idea of updating things as you go from left to right, so that you update the answer and you update what you're updating the state so that you make it available to be used in the future. So this idea does come up a lot, both in say competitive programming and interview, just because these problems does show up. And sometimes it's not even necessary that you use this idea, but once you have this idea, it becomes a lot easier. But this is of course a easy example of that, but that's what I would say. So let's just say, like I said, we have a lookup table, we have a collections.counter, say, so maybe we should use that thing, but then now it's just simple, right? So for x in nums, for every number, we check whether, if x minus, which way do we have it? I mean, x plus k, we don't really have to worry about, because addition is commutative, right? So x in lookup, so now we have a total answer. Then total lookup x plus k, right? So this part is pretty. Let me see. Well, if x minus, maybe this is wrong actually. Okay, let me actually. I think I skipped a step, so that's why this looks a little bit awkward. But basically, you want some x plus y is actually, okay. So you have x minus y is equal to k as an absolute value, right? So now, or instead of y, maybe p for previous value. So then now the two things, right? So there's x. I guess this is I minus j, but it doesn't really matter, right? There's x minus p is equal to k, and then there's x minus p is equal to negative k, right? So those are the two ideas, and of course you can put the signs on the other one as well, but same idea. In this case though, so we have these two things. Let me actually rewrite this a little bit. That may actually even be wrong. Maybe I'm just like really bad today. But the idea is that, okay, now you move, we know what x is and we know what k is, right? And we're looking for p. So then now x minus k is equal to p is what this formula reduces to, right? Sorry, I feel like in the past maybe I skip it a little bit too hastily. But in this other one is x plus k is equal to p, right? So that's basically the two things that we have to do, the two cases of p, and here now we book it down. I feel like, and that's my fault. I sometimes, to me, these things, I wouldn't say it's intuitive. Like sometimes people may say it's intuitive in a way, but I think it's just muscle memory, really, in that I've done I played with the idea of absolute value enough times that I know what it translates to in in a quicker way than, but you can definitely obviously see what I did, and what I did here took like an extra 20 seconds, maybe a minute, because I'm explaining it. But it's not that bad, right? It doesn't require any crazy knowledge. It just requires, thinking about a problem in a certain way. Anyway, so we have these two things. So we're looking for previous numbers. So a previous number that already exists in an array. So then now we know that we can do x minus, oops. Okay, because now that means that for every number that's in this basically is the count of, well, in this case, this is p, right? This is p, this formula that we have here. This is the number of times that this has the x minus k number, the p number, has happened previously, right? And the current number x makes one pair with each instance of x minus k. So that's why this is how this formula comes about. And of course, this is practically the same with the other one, right? So yeah. And then afterwards, like I said, you have to update the state. And that's what we'll do, lookup of x, because now we're saying to the future, hey, this x is available to be matched. And then I think that should be good. I hope this is good, because otherwise I said a lot of things to solve it the wrong way. Also, it's not, if you see me do these problems before, you'll also know that sometimes I misread the problem and I solve the problem for a long time, solving the wrong problem for a long time. So okay, and it seems like that we have the same instant here. Okay, number of unique K-diff pairs. What is that? Maybe I misunderstood what they meant by unique. Oh, okay. So it seems like what they, again, just as I mentioned it, so it seems like I solved the wrong problem, where in the way that I did it, 1 and 3 appears twice, so I counted as 2 pair. So now we have to fix it a little bit to make sure that it's unique. And what is the best way to do that? Well, I think we can just probably keep track of a set. Let me think whether we can do better. So there are 2 types of optimization that we can do, actually, right? One is space optimization, and then the other is time optimization, right? For space optimization, all we have to do is sort the number of nums, and then we can just look at a number that is smaller or something like that. And then you can, because nums is sorted, you can do a very easy trick to see if we already used the number because they're next to each other. So that will give you n log n time, but of n space, right? For the sorting. Another way that you can do it, I guess it's still of n space, so maybe this one is strictly better, is actually just keep track of the smaller number. If you keep track of the smaller number, then that's how you dedupe. You dedupe a pair by the smallest number, and that's pretty much the idea. So you would just have a set of either a set or yeah, I guess a set, right? So let's do it. Let's say scene is equal to set. If this is in the lookup, then all we have to do is, instead of having total, you see Larry solving bonus question. So x minus k is in lookup, right? So p is going to be the smallest number, right, in this case, because by definition x minus a number is going to be smaller because k is always positive, right? So yeah, so that's a smaller number. Here, as we said, we want a smaller number, and if we have x plus k, then the smaller number is x, right? And then that's pretty much it. And here, in this case, we don't even keep the count anymore because it doesn't matter because we dedupe, so we can actually change this to a set and also look up at set, right? And I guess here we have to change pretty much everything, really. But here we just change to the size of scene. I think this should be good. Hopefully. I mean, otherwise I have just typos or something. But yeah, I think this is okay. Let me think about it for a second. I think this is okay. I mean, unless there's some constraints I'm not aware of. There is negative number, but k, like I said, there's k, so I think that should be okay. We don't have to worry about the directionality of how we do the dedupe. Let's give it a submit. Hopefully that's good. Apparently I have 2 wrong answers in the past. Hopefully this time I don't, and I don't. So now we have a 680-day streak. Cool. As I already mentioned, this is linear space and linear time, and this is all of one. So yeah, cool. I think that's all I have for this one. I'm gonna see what I did previously. I guess I had the same idea. Wow, this is actually just really weird. Oh, Larry, just try to be too clever. I think I did some math of the counting, and then I just deduped by doing that. But I think it was adding itself to itself or something weird. I don't know. What about the second one? I probably tried to fix that answer and then did not do it correctly. And then the third time I just reset and probably do it correctly, maybe. Oh no, I still, So I guess there is a right answer using this technique, but I think I probably just misread the problem as well. This is like way yuckier, so I'm glad that we don't, I don't handle K00 apparently. Maybe that's the thing. Oh, because then the deduping thing is a little bit awkward. Okay. How did I do it a year after that? Or not even a year, just, oh no, a year. Okay. Oh, so I did the same thing here with what I did today, except for instead of deduping with the lower number, I dedupe with the higher number. Okay, so same idea, same coolness. I even labeled things a little bit better than I did this time, but hopefully the math is a little bit more straightforward. Cool. That's all I have for this one. Let me know what you think. Let me know how's it hanging, how's it chilling. Stay good, stay healthy, to good mental health. I'll see you later, and goodbye.